Today's lesson is on measuring area. Length is a one-dimensional measure of distance. For instance, when we're doing perimeter, we measure the outside dimensions of an object. Area is a two-dimensional measure of a flat space that covers the shape. So we would be measuring all that you see in the yellow, the entire covered space. When we measure area, we measure in square centimeters or even sometimes square meters. In this case, we're measuring in square centimeters. We see that the covered area has 24 squares covered in the yellow, so we would say that that shape has an area of 24 square centimeters. To find the area, you can just count each of the squares individually. You can skip count them as you would in an array by 4s or by 6s. Or, if you know your multiplication facts, you could multiply 6 times 4. Here is another shape that has an area of 24 square centimeters, just laid out differently. This time, our shape is 12 by 2. So again, you could count the squares individually. You could skip count by 12s, by 2s, or you could use multiplication. 2 times 12 is 24. A square centimeter has no specific shape, meaning it doesn't always have to look like a square. Here are some pictures of a square centimeter cut up and laid out differently. They are all still 1 square centimeter, even though they look different. The area does not change. Let's look at some examples. If I take this square and I cut it into half to look like that, and then I lay it out, it may look like this, but it's still the same area, 1 square centimeter. If I then take that square and cut it into fourths like this, and I lay it out to look like that, again, it is still the exact same area, 1 square centimeter. Here are some more examples. I can take that and make it look like this after cutting up the square. Or I can cut it into diagonals like this, and it ends up looking like triangles. However, again, all of the shapes here are still equal to 1 square centimeter. The area does not change at all. It is the same when working with meters. We would say that this square is 1 square meter. And then we see the model of the rectangle. There are 24 square meters in that rectangle. Again, I could count each of the squares individually. I could skip count them, or I could multiply the two sides, 4 times 6. So, as I said, the area of a rectangle is the product of its length and width, which just means the answer to when you multiply the two sides. 5 times 3, and that would give us 15 centimeters squared. Let's try doing some examples together. So if we look at rectangle A, we can see that the length is 5, and we can see the width is 3. If I were to multiply the two together, I would get 15 centimeters squared for that first area. In rectangle B, we can see that it has a length of 6, and we see that it has a width of 3. 6 times 3 will give us 18 centimeters squared. In rectangle C, we see that we have 7 centimeters in length, 3 again in the width. That gives us 21 centimeters squared. And finally, in square D, we see the 4 by 4, and 4 times 4 is 16 centimeters squared. Now, if you can't remember how to do your multiplication facts, remember, you could skip count by 5 3 times for A, or skip count by 3 5 times. Same with the other rectangles and squares. That might make it easier for you if you can't remember your multiplication facts. So again, here is the chart completed, a little neater for you. Just remember to add in your units of measurement, which is centimeters squared. They didn't have that on the chart, so I've added that in. And the little 2 just stands for the fact that it is a two-dimensional thing that you are measuring. Like I showed at the beginning of the video, length is one-dimensional when we do perimeter, but because area is covering an entire surface, we call that a two-dimensional measurement, which is why you see the 2 beside your unit of measurement. sometimes we'll be given a chart where we have to determine what the width might be, judged by the length and the area that we're given. So if we look at shape F, E was already done for us, so this would be rectangle F. We know that the length of the rectangle is 6 centimeters, but we don't know what the width is. We do know, however, that the area in total is 18. So we have to ask ourselves, what times 6 would give us 18? Maybe I can skip count by 6s until I reach 18. 6, 12, 18. How many times did you skip count? 3. So I know that 3 times 6 gives me 18, so the missing side length must be 3. I can write that out in a multiplication fact. So for rectangle F, 6 times 3 equals 18 centimeters squared. Let's try another example. In rectangle G, we can see that one side length, the width, is 6, and our area is 36 square centimeters, but we don't know the length. Again, we can skip count by 6s until we reach 36 to figure it out, or if you know your multiplication facts, you can ask yourself, what times 6 gives me 36? And if you know the answer to that, the answer is 6. 6 times 6 is 36, and you can write it as a fact. 6 times 6 is 36 centimeters squared. Hopefully this little video has given you a better understanding of area. And remember, if you're using a rectangle, the formula for area is length times width.